This video is about absorption spectra. To understand how an absorption spectrum is formed, we'll again start with a gas cloud. As the first step, we will shine white light on the gas cloud. A quick reminder here that white light contains all the colors on the visible light section of the electromagnetic spectrum. After the light emerges from the gas cloud, it is passed through a glass prism and forms an absorption spectrum on a screen. This is how this spectrum looks like. Using the same gas, we can also create an emission spectrum, which looks like this. As a reference point, here is the full electromagnetic spectrum. As you can see here, the absorption spectrum is almost the same as the full electromagnetic spectrum, except that it has some vertical black lines. You can also see that these black lines occur exactly at the positions where the colorful lines occur on the emission spectrum. Let's use an energy level diagram to explore how exactly an absorption spectrum is formed. As we said, white light is made up of photons that carry different amounts of energy. Photons towards the red end of the electromagnetic spectrum carry less energy, while those towards the violet end of the spectrum carry more energy. Remember that energy levels are quantized, which means that in order for electrons to transition from a lower to a higher energy level, they must receive a specific amount of energy all at once. Some of the photons in the white light carry the exact amount of energy that is needed for the transitions to take place. This energy level diagram has 6 possible transitions. Therefore, there are 6 different types of photons in terms of the energy that the photons carry that will be absorbed by the electrons in the gas atoms. Since these photons are absorbed, they do not reach the screen where the absorption spectrum is formed. As a result, we get black lines at the positions where these photons would usually arrive at the screen in the full electromagnetic spectrum. Each energy level transition shown by the arrows corresponds to one of the black lines in the absorption spectrum. The longer the arrow, the more energetic photon it represents, so the corresponding black line will be closer to the violet end of the spectrum. Let's talk a bit about the emission spectrum. We learned about emission spectra in the previous video. When the emission spectrum of the gas is formed, the same photons are emitted by the electrons in the gas. Therefore, the colorful lines in the emission spectrum are exactly at the same positions as the black lines on the absorption spectrum. Let's sum up what we just discussed. White light contains photons of all energies from the visible section of the electromagnetic spectrum. Energy levels in an atom are quantized, so electrons in the gas atom must gain a specific amount of energy all at once in order to transition to a higher energy level. Photons that correspond to these specific amounts are absorbed by the electrons in the gas atoms. As a result, these photons do not arrive at the screen, so we see a black line at the position where these photons would occur on the full electromagnetic spectrum. The black lines on the absorption spectrum are at the same position where the emission spectrum lines are, because they correspond to the photons with the same amount of energy. This completes our discussion of absorption spectra. In the next video, we'll learn about radioactive decay.